Okay, Foundation and Pre-Calc 10, let's get after it. Here we go. We are going to look at some word problems involving trig. So this is all going to come down to vocabulary. So first thing to consider is angle of elevation. The angle of elevation is created from the horizontal at the bottom, okay? If you're down here and you're looking up, your angle of elevation is created right in there, okay? Now, the angle of depression is almost counterintuitive because a lot of people would look at a line going down and think that the angle of depression would be if you drew kind of a line like that, right? What's the angle of depression? Some people get a little confused, but it's the angle created with the horizontal again. So if the person is here and they're observing down there, it's not this angle. Okay, it's the angle created with the horizontal. So it's the angle created with the horizontal here. So if you had a triangle, the angle of depression would actually be up here. Okay, so just be aware of that vocab. The other vocab is navigation bearings. So if you see something like this here, okay, N52E, the first letter is where your rotation starts, and the second letter is the direction of your rotation. So 52 degrees, that's east of north, which means you were north and you've rotated to the east, 52 degrees. This is 63 degrees east of south. So you were south and you rotated east. You were north in this case and you rotated west. So the second letter is the direction of rotation. The first letter is where you started on your compass. So that's often misrepresented. So careful there. So let's just look at a couple examples, okay? So you're flying a plane and the angle of descent, which is the same as the angle of depression, is 8 degrees. Okay, so what does this look like? The plane is traveling at an altitude of 10,000 feet and the airport is here. Okay, so here's my airport. Here's my plane, way up here in the sky. Nice drawing, I'm the best. I am such a good drawer. Right, there's my airplane. And it needs to travel at an angle of descent so that it lands at the airport. So this is 10,000 feet, and my angle of descent is not in here. Okay, don't make that mistake. Remember that the angle of descent or the angle of depression is this angle right here. Now, how is that helpful? Well, if that's 8 degrees and this whole thing here is 90 degrees, well then this bit here is the angle we can use, 90 minus 8, which gives us an angle in our triangle of 82 degrees. So now we have a triangle with an angle inside of it. So we have the angle, we have the adjacent side, and we want the opposite side, right? We want to know how far away horizontally the airport was. So opposite and adjacent means tangent. So tan of 82 degrees is equal to x over 10,000. So 10,000 times tan of 82 is equal to x, which means my horizontal distance is 71,154 feet away. So when you are that far away horizontally, start your descent at 8 degrees, or 8 degrees of depression, and you will arrive at the airport on time. Now, you might look at that and think that's a very long distance, but remember that it's only in feet, so it might not be that far at all, and you are 10,000 feet in the air. So you want to go down at a relatively slow pace. But that's how you tackle a question like that, and it involves a little bit of a beautiful drawing. It's drawn by me. So let's look at another one. The equal sides of an isosceles triangle. Oh, okay, so that means this side here and this side here are 30 centimeters. Okay, the third side is 36 centimeters. So determine the measure of the interior angles of the triangle. Okay, so what is this and this? Remember, those angles are the same. And then we'll need the top angle. Well, this kind of breaks down to similar to our special angles. We can drop a perpendicular here. Dropping a perpendicular creates a right angle triangle. And it splits this in half to 18 and 18. So you can solve either one of these. It's the same triangle both ways. But what you have is, if you're solving, let's solve for this angle here. We have adjacent and we have hypotenuse. So cosine of angle theta is equal to 18 over 30. So cosine of theta is equal to 18 divided by 30, which is 9 over 15. So 0.6. So we are going theta equals cos -1 of 0.6. And we get an angle value there of 53.13. So let's round it, in this case, to just 53 degrees. In the notes, it's rounded to 53.1, but I'm just going to do 53 for the sake of simplicity. So that means we have solved now for this angle. It means this angle is the same. So we have one angle that's 53, we have another angle that's 53, and then remember that all angles in a triangle add up to 180. So 180 minus 53 plus 53 is 106. That will give us our third angle at the peak. So we end up with the angle of 180 minus 106, 74 degrees. So we have angles 53, 53, and 74. So here are the visuals given to you, but you'll have to draw the visual yourself in many instances. So just be prepared to do that. So let's look at another one here, okay? So in this case, we're going to deal with some bearings. And I want to take my time here because I really want to help you kind of get an idea of what this looks like. So a surveyor is laying a road due east from A, and they encounter a lake at B, okay? So let's just say here's A, okay? The surveyor is starting. And if they're moving due east this direction, and they encounter a lake here at B. So draw your lake. And they're building a road. So they got a bit of a problem, okay? So she changes her direction when she's at A. So she changes her direction before she gets to the lake because she sees the lake. So she changes her direction 33 degrees east of north. So if this is north, remember it's where you start and then your rotation goes this way. So she changes her direction to here. So this is 33 degrees in there. Well then, what's the angle inside my triangle then, right? The angle inside my triangle, and I'm just going to draw this a little bit lower so we have some room. So here's A. I see my lake here at B. And I change my rotation so that I'm eventually going to be in line with my lake. But this angle here is 33 degrees east of north. So it means this angle here, well, that again creates 90-degree angle. So that's got to be 57 degrees. So now I have an angle inside of my triangle. And she changes her direction to get to point C. So here's point C, and it is 2,400 meters away. So now you have the hypotenuse of that. Okay, and then once at point C, she turns south of east. East of south. So if this is south here, I'll now add it into red. Okay, here's south. I'm turning east, so that way. And then she travels all the way back down to miss the lake and arrives at point D. And the question then is how far does she have to continue down from C to D in order to intersect her original idea for the road? Okay, so that's what the road is supposed to look like, and she wants to arrive there. So we have a rotation of 57 degrees east of north, or 33 degrees east of north, which gives us 57 degrees on the inside. And then in here we have 42 degrees east of south. So we have a bit of missing information that we're going to need in order to solve. Because what we have here is we have we got a right angle triangle and we got a right angle triangle. So I'll outline the first right angle triangle here in white. So we have this first change, okay? So this here. What we have is we have the angle 57, we have the hypotenuse, and we need h, we need the height, which in this case is opposite. So in order to get that, we're going to use sine, opposite and hypotenuse, of 57 degrees is equal to h over 2400. So 2400 times sine of 57 degrees is equal to my height. So I run that calculation, and I get that 2400 times sine of 57 is equal to 2012.8. So it means the height is equal to 2012.8. And yeah, we're talking meters, but so that's this value in here. And now consider in, let's maybe change to blue, pink. Yeah, let's go pink. Now we're looking at this triangle here, okay, where it's still a right angle triangle. We have this value, but we want to know this value. Okay, so, or sorry, we don't want to know that value. We want to know how far down C to D she has to travel in order to connect. So we want to know this value. So again, now we need the hypotenuse, but if our angle is in here, we have the adjacent side. So we have cosine of 42 degrees is equal to h over x. And we know that in this case, h is 212.8. So we have to do our fancy algebra here. So x equals 2012.8 divided by cosine 42 degrees. And we end up with the diagonal value there, how far we have to travel, of 2,708.5 meters. So we've solved for this value here. We've solved for traveling from C to D. So this is probably one of the most confusing questions you'll have, but I wanted to show you one with respect to bearings. So that's it for trig. Trig is going to come back fast and furious in grade 11, and then you're going to get a double dose of it in grade 12. So try your best to get as comfortable as you can with it. If you want to see some short videos, please just plop it in the comments, something you'd like to see a little bit of extra detail on. I'd be happy to take care of that for you. Okay, so great work and keep it up.